with last time. It says at time t equals 0, a diver jumps from the diving board 32 feet above the water. That's some nice information and everything, but really it gets into it. It says the position of the diver is given by this equation right here. S is measured in feet, T is measured in seconds. Find two things. Number one, find when the diver hits the water. What kind of a question is when? That's a time question, so it could say find the time when the diver hits the water. And then after that, we're going to try to find the diver's velocity. And this little phrase at the end should kind of pique your interest. At impact. Impact sounds a little gruesome. They're just diving into the water. But at, what about that word at? What does that imply? At a specific time. Not an average velocity like from the top to the bottom or something like that, but at that moment when the diver actually hits the water. That makes sense? Anyways, let's find when that time is. Any ideas on what we could do to find the time when the diver hits the water? Like one step to kind of get us started off? What do you think, Kayvon?
Could you put the position at 0 and solve for t?
Yes, that's exactly. Does his strategy make sense? So if the diver starts off 32 feet up above, when the diver hits the water, it's going to be a height of 0. I think that makes a lot of sense. Let's do that. So I'll do that over here. 0 equals negative 16t squared plus 16t plus 32. Any strategies on how you could be efficient about solving this? Close. Real close. How about deal with a negative 16, right? That'll make your lead coefficient positive 1 instead of negative 1. And I'm not just going to factor it out. I'm actually, because it's an equation, I can actually divide by negative 16. If it wasn't an equation, you'd have to factor it out. But aren't you allowed to divide both sides by the same thing? So that's what I'm going to do. So Kayvon, you are on a roll. You've started us off really, really well. So 0 equals t squared minus t minus 2. If you divide a negative 16 out of every single term on both sides of the equation. And hopefully that suggestion helps to solve this. What would be another good step? Factoring, yeah. So hopefully you just do a quick quadratic factoring here. 0 equals, I think, this. And then set each factor equal to 0 and solve that 0 product property. So I'm coming up with two different times when the height is 0. T equals 2, t equals negative 1. We reject one of these, right? Based on the fact that it's a diver diving off of a board. Which one do we reject? Yeah, because he can't hit the water 1 second before he jumped off of the diving board. That's what that means, right? And so that's impossible. But 2 seconds, sure, that's possible. Okay, are you guys okay with that? How much calculus did that involve? None. No calculus. That's just some algebra. Not easy, but it's just algebra. Okay, calculus. So we know it's going to take 2 seconds for this person to hit the water. Now we want to find their velocity at impact. Awesome. Let's just take that 2 seconds and plug it into the velocity function. Except there is no velocity function, right? Yeah, there it was. Who was that? Yeah. Dax is on it. You guys probably were maybe right there with him. We take the position function and we differentiate it, right? We do the derivative with respect to time. Remember the derivative of a position function this is the thing we finished with last time. Derivative of position will give you a velocity function. The rate of change of position, velocity. Okay, so let's practice our power rule here. I'm going to say S prime of t is equal to V of t. And let's practice. Let's just go term by term here. What's the derivative of negative 16t squared? Negative 32t, yep. And then plus, what's the derivative of 16t? 16. And finally, what's the derivative of plus 32? Right, that's right. I'll just leave that off. Okay, so then this negative 32t plus 16 stands for the velocity at any time. We don't really care about what's happening at any time. We want to know what? When t equals 2 seconds. So I'll say something like S prime of 2 is equal to V of 2. And that would be, negative 64 plus 16? I got negative 48. I think, yeah? Yeah. What kind of units would go with that? I think it's feet. If it were measured in meters, we go meters per second, but I think it's feet per second. Okay, a little bit of calculus there. Obviously, you had to do the derivative to the position function in order to get the velocity function. Make sense? Okay, fantastic. Are there any questions at all? I'm going to say this, and this video is recording here. I want to say you guys are doing a fantastic, awesome job keeping up with the intro videos. I checked like late last night, I think it was, just these, just kind of see where's everybody at, is anybody kind of doing it at the last second? And everyone was done. Like, they were all green bars. I was like, whoa, let me just check that again. I scrolled, and like, everybody did it. How beautiful. It's so awesome. So I encourage you to keep that up. Hope that's helping you. We're going to see right now. Okay, so let's move ahead. And let's take a look here at something that we will use. We'll definitely build upon this as the year goes on. So product rule and quotient rule. So can I set the stage here for you? You saw this in the video, how, number one, you can differentiate using a power rule. Number two, you can differentiate using a power rule. But then when you get to number three, the fact that it is a function times some other function means that another strategy has to be used. And so I think, it's right there in yellow. I mentioned this in a video, I'm sure. I will do my best. We will practice this a lot. But a lot of times, the main struggle is I just didn't see it. I just didn't recognize. Bless you. And so I think we're just going too fast when people do that. They just don't realize, hey, it's multiplication instead of addition. I mean, that's really what it comes down to. So we'll try to drill that really, really good. And we're going to start off with number two. We'll just kind of pick our way through the notes. Kind of curious to see what you guys can do with this. I think if you watch the video, which according to the computer y'all did, and if you know how to do the power rule, which I've seen you do, I think you maybe can handle number two, or at least in part. So give it a shot. Why don't you work together with a friend, or maybe work on your own, and we'll check your answers here in a second. Do you guys remember that the little saying in the video that helps you remember what to do in order to execute the product rule? 1D2 plus 2D1. Okay. I've got a quick question for you. So I know that the DC pre-calc classes, they do a little bit more with this kind of stuff versus the regular pre-calc sequence. And I think, real quick, will you let me know, how many of you did DC? I'm just kind of curious. 1, 2, 3, 4. Okay, cool. I was just kind of curious. So, you guys did do product rule, right? Yeah. But regular pre-calc did not. I'm right? Okay, I thought this might have been where it split. Okay, I was just kind of curious. Okay, cool. So 1D2 plus 2D1. And so Mr. Blake and I have, we used to teach out of the same kind of book, and that's where this 1D2 plus 2D1 thing comes from. And so I like that as well. So I think you guys probably heard that. Plus the loading high minus how you lower the square what's below, that whole thing. Okay. Anyway, so that's the kind of the key to me, at least, to remember how to do this. So I'm going to write f prime of x is equal to 1. So 1 just stands for the first factor, unmodified, right? So you just write the first one, 2x cubed plus 4x. And then d2 stands for the derivative of the second one. So the derivative of sine is cosine. Yeah, so this right here would be 1d2. Make sense? 1 times the derivative of the second one. The first, yeah, okay. All right, then plus 2. That would just be the second factor. And then d1. d1, we just use the power rule twice. So are you guys okay with 6x squared plus 4? Okay, let's think about what this is. Of course, this is f prime. It's the derivative with respect to x. Couldn't we also say that that's the slope of the tangent line? Same thing, right? It's the slope of the tangent line at any x. And did this question ask us to just find it for any x? What did it direct us to do? When x is 1, right? So at this point, once you found f prime of x, this is when you plug in the 1. So f prime of 1, I'm okay if you do some of this in your head. And obviously with a 1 in there, it's going to be pretty straightforward, right? So if you plug in a 1, that first factor is just a 6. So this would be 6 cosine of 1 plus sine of 1. And then I guess that would just be 6 plus 4 times 10, something like that. And we're done. Like if this was a no calculator question, which I can very much see this being a no calculator question, I don't really know what cosine of 1 is, and I'm guessing you don't either. And so we just stop. It's not cosine of pi, right? It's tempting to think that cosine of 1 is going to be a unit circle, but it's not. Cosine of like 0 is 1, but cosine of 1 radian? I don't know. No, I don't think so. That's definitely not 1. Yeah. Could be in the wrong mode. But even, yeah, you're in degree mode, aren't you? Yeah, because cosine of 0 is 1. Yeah, that makes sense. Okay. So maybe we leave it that way, because you want to know the honest truth? If the calculator was active, we would not have done any of that. I'll tell you about that later, okay? If the calculator was really active, we would have done none of that, and it would have been done quick. I'll tell you about that later. Anyways, any questions? You guys all okay with the whole 1d2? I forgot the other part. Plus 2d1. Is that good? Okay. All right. So then I think number 3 is another excellent one. Please notice that number 3 is a little more symbolic, right? And sometimes people are a little uncomfortable with the notation of this. That's why I put this in here. So if you guys would, take a look at number 3 if you haven't already, and see if you can kind of navigate what it wants us to find, right? It's not totally clear. Take your time, read it over, see what you come up with. We'll check your answer in a minute. It's a paragraph, right? Like you look at it and you're like, whoa, this is not math, but it really is. It's paragraph kind of scary. This is starting to get into that realm, but there's a lot of symbols. I mean, honestly, can you identify with somebody that maybe would look at this, and then look at this, and then look at this, and then see all these symbols, and just be like, asking this question, what on earth am I supposed to do? Can you see how somebody would say that? So let's pick this apart a little bit, because I think that if you feel that way, I need to help you. So I want you to stop and think for a second. There is one key word in this whole deal that says essentially do this. Like it gives you very clear direction. What is that one word? Find. Right? So let's go here and let's highlight that. So it says find, and it specifically says find h prime of 2. And so what this should do, this should give you some direction. Let me kind of explain what that direction would be. If you're going to try to find h prime of 2, here are your steps. Number 1, find h prime of x. Because if you're going to find h prime of 2, you need to figure out what h prime of x is first. And then step number 2 would be to plug in a 2 for x, right? Plug in a 2 for all the x's that you see. So step 1, if you're finding h prime of 2, is find h prime of x. Bless you. And, sometimes, have you guys seen the joke? Like the math joke where like the math teacher has written a quiz where it says find x, and the kid just like circles x? You seen that joke? Yeah. So I do have, I don't know if it's good news or not. I do have news for you on that. There will be times when I say find this or find that, whatever it is, and it's like a derivative, let's say, or something related to a derivative. And believe it or not, there will be times when in the body of the question, I'm going to give you the derivative. Like straight up. No screwing around, no tricking you, no nothing. But you know what sometimes people will do? They'll take that thing and they'll do the derivative of it anyway because they're just in math robot mode. They just differentiate everything they see. And so you might think, well, how dumb is that for you to ask me to find the rate of this or the instantaneous rate of change of that or something, and then you give that to me, at least in part, right? Like how silly is that? You would not believe how many people they just differentiate it just because. That's just what you do. So the idea there is carefully read. So sometimes finding h prime of 2 involves, oh, there it is. And there it is. And other times you're going to have to differentiate, but it's never the same thing twice. So what am I trying to get at here? You got to think. You have to be on your toes mentally and be like, oh, he gave that to me. Cool. Or he didn't. And I have to do some power rules or whatever. Make sense? So you say find h prime of 2. You look through the rest of the question. Do you guys see anything about h prime of x anywhere? What do you see, though? I see h of x. So are you starting to get this figured out where it says all these symbols, and you're like, why do you know where to start? Start with the word find. And then you start to get a little direction. All right, well, I'm going to find h prime of x first. All right. Well, there's h of x, so I do have to do this derivative. And it is a product. And so I'm going to have to use the product rule. So I'm going to say h prime of x is equal to 1. That's not too hard. What's the derivative of f of x? F prime of x. Correct. Good. So cosine of x times f prime of x, that's 1d2, plus 2 is f of x. And then how about d1? Say, yep, negative sign. Very good. So negative sign of x. Let's go back. Remember, we were kind of confused at the start. There's all these symbols everywhere. I didn't know what to do. The word find gave me direction. Find h prime of x first, which we just did. Now we plug in the 2 for all the x's. So h prime of 2 is equal to cosine of 2 times, well, I know what f prime of 2 is. What's that? That's right there. That was one of those symbols that was confusing us at the start. So I could just write times 4 there perhaps, or I could write f prime of 2 and then later on turn that into a 4. That's fine. Plus f of 2. What on earth is that? Hey, negative 3. So negative 3 times negative sine of 2. And once again, if this was a no calculator question, which I think it probably would be, no calculator, we could leave it just like that. We could clean it up a little bit and say it's really, 4 cosine of 2 plus 3 sine of 2, maybe something like that. I don't know, whatever.
And you can't multiply the 2 times the 4 because it's cosine of.
Yeah, it's cosine of 2, so that's your input for cosine, and the other 2 is the input for sine. So yeah, you just leave it as is. Yeah. Okay, so I want you to stop and think for a second. I hope the answer is yes. Did that discussion of like, what do I do, that help a little bit? Because I think that's one thing that we as math teachers, we need to like get out of our own heads a little bit, because as a math teacher, I read that and like instantly I know what to do. It's easy to forget that sometimes it's really hard to be like, nice, what do I do with this, right? And so breaking it down like that can make a big difference. We'll keep doing that for sure. Are you guys okay? Good. I'm sensing you're okay. Okay, cool. All right, well then let's move on. I think, yes, the next thing is the quotient rule. Video started again. Remember the little phrase was low d high minus high d low over the square of what's below? Okay, so we're going to do an example of this. And this again would be definitely a no calculator. I'm guessing the answer might be somewhat unsatisfying. I'm willing to bet probably, but that's okay. Okay. This was a little more clear. Do you guys see the keyword that tells you what to do? Find. Yeah. You would be amazed. Like, I think you'll be amazed. I think you'll be happily amazed. Like when we start doing word questions, like, the question is actually like a paragraph with like 3 or 4 sentences and all that stuff with symbols and everything. And honestly, you look at it and like, I wouldn't be upset with you if your head like figuratively kind of exploded when you looked at it. You're just like, what? How am I supposed to do this? You'll be amazed when you start to pick these kind of questions apart, even really simple ones like this. The word find is in there all the time. It's basically saying, hey, attention, over here. Do this. Figure this out. Versus the whole, oh my gosh, there's words and I can't do this. Very different, right? So we'll look for those words. This one's pretty clear. Okay, so if I'm going to find g prime of pi over 6, I have to find what first? G prime of x. I've got to find that first, and then I can do the whole pi over 6 thing. So if I'm going to find g prime of x, probably the first thing I'm going to look at up there is say, whoa, that's a fraction, right? And so probably the easiest, there are other ways to do this, but probably the easiest way would be the quotient rule. And so this is where we're going to identify this down here as, I'll do it right over here. This is the low, this is the high. So when you think of that little phrase in the video, low d high minus high d low over the square of what's below, now you have your high and your low. Make sense? And it should rhyme. If you go high d low minus low d high over the square of what's high, it didn't rhyme, right? It better rhyme, or you're saying it backwards, right? And it matters, right? You guys realize that 1d2 plus 2d1, the ordering doesn't really matter because you're adding. But with this, because it's subtraction within the quotient rule, the order very much does matter. So you want to be careful with that. So here we go. I don't know. Can you guys do this one? If you watch the video, why don't you give it a shot? I'll let you just go with it, and we'll just check your answer, and we'll do Q&A as needed. I'm willing to bet you guys can probably do this. And I will say this, simplify any trig you see. Simplify trig, but the other junk you don't need to simplify. Like if it's like pi over 6 squared, whatever. I'm not too worried about that. Kind of compare. So low. Low is just going to be the polynomial, the denominator there. So we're going to go parentheses x squared minus 3x plus 8. I'm sure you realize this, but the parentheses really have to be there. It's not really an option. Okay, so there's low, d high. What would d high be? 9 cosine x, I agree. So there's low d high minus high would be 9 sine of x, parentheses d low, 2x minus 3, again using the power rule. So yeah, 2x minus 3. So there's the numerator of that. Are you guys okay with the numerator? Okay. All right, so then all of that over the square of what's below, x squared minus 3x plus 8 quantity squared. Okay, so then what follows here, of course, if you're finding g prime of pi over 6, you got to find g prime of x first. We have that. Are you guys okay? Totally good? Now we just have to plug in the pi over 6 for all the x's. And the only reason I'm going to go all the way through with this, I'm not going to figure out what pi over 6 squared is, certainly not with a decimal. So I've got pi over 6 quantity squared minus 3. I guess I could just write it as pi over 2, huh? Cancel out the 3 and the 6. Plus 8. What I really wanted to get to here was what is cosine of pi over 6? I don't want a decimal. I want to...
Isn't it like square root of 3 over 2?
It's either 1/2 or it's root 3 over 2. It's one of those. So you want to, if I ever have a weak moment and I'm like, I can't remember, what I usually do is draw a triangle. Pi over 6 goes here. That makes this a 1, a root 3, and a 2, right? And we're doing cosine. Cosine is adjacent over hypotenuse, so I think this would be the root 3 over 2. Make sense? Okay, so I will write that here as, I guess it'd be 9 root 3 over 2. Minus, we're right up against another unit circle, and I got that triangle up there, so what's sine of pi over 6? There's our 1/2, right? So you could write that as 4.5 or 9 over 2, whatever. And then, of course, 2 times pi over 6, again, is just pi over 3 minus 3, and then all this junk down here. Again, I'm not hyper concerned about. I guess I could cancel out again. Pi over 2 plus 8, quantity squared, whatever. I wanted to make sure you get a little practice with the unit circles, kind of the main thing there. Okay. And believe it or not, like I would definitely take an answer like that, right? I mean, what else would I really expect you to do with that in a reasonable amount of time? I don't know. I guess you could do some simplifying, but that's good. It's plenty enough. All right. How we doing? Doing okay? All right, so there's a danger in this. It's not that dangerous, but here it is. Danger is to your time and your mental energy. So, have you ever heard the phrase, to a hammer, everything looks like a nail? To a hammer, everything looks like a nail? And so sometimes, like, you'll get good at some skill like this, right? You'll see, you'll get really good at the product rule, you'll get really good at the quotient rule, and then basically you get good at it, and you're confident, and that's great, but then everything starts to look like that, right? You're like, oh, it's a quotient rule, when maybe it would not be best suited to be a quotient rule. That's what this next section is about. So take a look here at number 6. So first of all, can you see why someone maybe would look at number 6 and be like, quotient rule? It's a fraction, right? And there's a variable in the denominator. And the truth is the quotient rule would work fine. It would work totally fine. No big deal at all. You go low d high minus high d low over the square of what's below. You get this kind of complicated looking fraction, right? It would be, if you did it right, it'd be accurate. It'd be no problem at all and never mark that wrong. But if you rewrote it, it'd be over with in like 10 seconds. So check this out. Any ideas on what we could do to rewrite this thing? Yeah, move that x up. and make the exponent negative. So you could write y equals 10 thirds x to the negative 3. So now that x is now up as a numerator, and as you said, the variable's exponent has to change sign. Whoa, this is way easier now. This is no longer a quotient rule. What is this? It's a regular old power rule, right? So what would happen here is you'd say y prime equals, and I'll show you all the little steps. 10 thirds stays there, times negative 3x to the negative 4th, right? I just did a quick power rule. And then even the 3's would cancel out. So this would give you y prime equals negative 10 x to the negative 4th. And of course, if you really wanted to, you could flip that x to the negative 4th back down and, whatever. Not a big deal. But, you'd save yourself some time and mental energy just by flipping up real quick and doing a power rule. This won't always work, right? It just depends on the situation. But this one would be just fine. Any questions there? In no way, shape, or form is this required. This is just intended to be a help to you. Yeah, go ahead, Eddie.
What if you brought the 3x to the 3 all the way up?
Are we talking about number 6 still?
Yeah.
Okay, so what if we brought the whole denominator up?
Yeah.
Okay, we can look at that. So if you did that, here's what it would look like. Y equals 10 times 3 to the negative 1, x to the negative 3. You can move the 3 up if you want, but you do have to change its exponent as well. So you could totally do this, right? So it'd be like what that means is that 10 times 3 to the negative 1, that's just a constant multiple. And so what you do when you do your power rule, you'd say y prime equals, the constant multiple just stays out of it, times negative 3 x to the negative 4th, and then we're back into basically the same place we were before. Does that make sense? Okay. Anybody else?
We're good.
Now, were you about to ask about the product rule?
Yes.
Yes, I'm glad you were.
So the 10 to the times 3 to the negative 1, it's a constant, so shouldn't it equal 0?
I know, let's be really careful with this. We talked about this, I think, the other day. So there's a difference between a constant multiple and a constant term.
Okay.
So let's just compare. So if I have this, but then I've got something else, I'll call it g of x just so it's named something else. Those are two totally different expressions, right? The one on the left, the 10 times 3 to the negative 1 is a constant multiple. And for a constant multiple, to differentiate something that has a constant multiple, what you do is you mentally cover that up, do all your derivative stuff, and then just multiply the constant multiple back in. Over here, this is not a constant multiple. It's a constant term. It's a whole separate term from the whole x to the negative 3. And so when you differentiate this, the derivative of that constant term, no matter how complicated or whatever it looks, is 0. I agree. Over here, though, what you would do is you would say y prime equals the constant multiple times the derivative of the thing that's not a constant. So deciding whether it's a constant multiple that you're dealing with or a constant term they're different. Okay. Any other questions? Is it really, real good? When did our class start? Is it?
11:50.
Was it 50? Yeah, 50, right? Yeah, okay, cool. All right, I'm just making sure that my time is gone. All right, so number 7. Do you see how number 7 is sort of tempting to use a quotient rule on if you're going to try to find the derivative? Why would it be tempting to do that? It's a fraction, right? So what could you do to make it much easier and also not a fraction, therefore not requiring the quotient rule? Yeah, just actually go ahead and do the division, right? I totally agree. So y equals 4x to the positive 1/2, and we don't even really have to write the over 1. Just write it as that. You can see now this gets way easier if you just say, hey, when you're dividing bases, you subtract your exponents, and you get 4x to the 1/2. Now, y prime equals what? That's right. You want to see what this looks like as a quotient rule? Check it out. I'll just scratch it out real quick. Y prime equals low d high. That would be 6x to the 1/2 minus high. D low is just 1 over the square of what's below. Shockingly enough, apparently, this and this are the same. We'd have to do some pretty serious simplifying on the thing on the right, but they're the same. You see why it might be easier to say, quotient rule, no. I will not use you right now. Might be easier. Sometimes you have to use it, but in these cases you don't. What do you guys think? All right, cool. Well, I don't know what's next. Let's find out. Oh, other trig functions. These are cool. All right, so I maybe will show you how to derive one of these derivatives, like where it comes from. But I put this over to the side. Bottom line is these have to be memorized. I hope that you trust me at this point that I'm never going to waste your time. I'm never going to be like, hey, memorize this stuff. But I'll never ask you about it. I'm not going to do that to you. If I tell you to memorize it, I will definitely ask you about it. So please be ready. Yes, ma'am.
Are you gonna make us prove them?
You eventually will be good enough to where proving them is non-issue. Like it'll be easy.
In pre-calculate or prove and says
Yeah, I mean,
I like to use it.
I never give away what's on a test or a quiz beforehand, but I will stand by my word and say, if we all do our jobs right, by the time we're done with this, proving them is like nothing, like super easy. So, I will say I will get you ready enough to where if I did ask you, you probably wouldn't break much of a sweat. That make sense? Okay. All right, so let me just run through what these are really quick. Let me just tell you what they are, and then maybe I'll prove one of them to you. Is that fair? Okay. So the derivative of tangent of x is secant squared of x. As of course, you guys I'm sure know that that's secant of x quantity squared, right? Sometimes that's a better way to write it. All right, so derivative of tangent is secant squared. The derivative of secant of x is secant of x times tangent of x. And from a memorization perspective, I think if you can memorize those two, I think the other two, like the cotangent, cosecant, kind of fall into place, like they'll kind of go together. So if the derivative of tangent is secant squared, what would you guys guess the derivative of cotangent is? You would think that it would maybe be cosecant squared, right? It's really close. It's negative cosecant squared of x. And maybe then you can get this next one. If the derivative of secant of x is secant of x times tangent of x, what would you guess the derivative of cosecant is? Yay, there you go. It's negative cosecant of x times tangent of x. Okay, so I don't know. You guys want to see tangent proved? This is the first one up there. All right, show it to you real quick, just so you kind of know where it comes from. What I'm going to do is I'm going to start off by saying derivative. I haven't really showed you that notation yet. So ddx is how you say that. ddx is it's an operator. Just the same way. Do you guys recognize that operator? What does that mean? It means add stuff together. What about this operator? How about this operator? Division. How about this operator? Yeah, so I'm trying to make a point here, aren't I? I know you know what those symbols are. So just like those symbols all have an operation associated with them, ddx is an operator. Like ddx is a verb. It's saying, hey, do the derivative with respect to x of this thing that follows. Make sense? It's telling you to do something. Do the derivative with respect to x. Anyways, with that in mind, I'm going to go ahead and manipulate this a little bit. Tangent does not have to look like that. If you use one of your little trig identities, tangent could be rewritten as? It's the other way around. Sine over cosine. That's right. So if I rewrite it like this, the derivative of sine over cosine, well, looky there. What do we have? A quotient rule, right? Because you're doing the derivative of a fraction of a couple of functions, and you have to do the quotient rule here. So here we go. It's going to be low d high minus high d low all over the square of what's below. So with any of these proofs, right off the bat, it might not look very promising. It doesn't look that promising yet, but let's do some manipulation. Look at the numerator. What's cosine times cosine? Yup. Okay, so cosine squared. And look at the second part of the numerator. What is negative sine of x times negative sine of x? Yay, plus sine squared. So, of course, this would be a really ugly move. Just watch this. Be embarrassed for me. That's a really embarrassing move, right? That's bad. I hope that you would not do that. You don't have to raise your hand and admit that if you would. I'm being silly. That's a bad move, though, right? We don't want to do that. What can you do with the numerator? There's a significant thing you can do. What is it? Yeah, it's Pythagorean identity, right? So the whole numerator is like 1. Yay. That's kind of nice. So then you look at that and you're like, well, how does this equal the thing that it's supposed to equal? What's the reciprocal of cosine? Secant. So this is equal to secant squared. Hey, it's the thing we were looking for in the beginning. So you could similarly prove the other 3 if you wanted to. I'll leave that up to you if you feel so inclined. The good thing about proofs is, don't you know that you got it right or wrong? You either got where you were supposed to go or you didn't, and you know if you cheated or made stuff up. So I'll let you explore as you wish. Okay? I think there's some application stuff here to finish up our class today. But do you have any questions before we do that? Okay. Remember, I said those need to be memorized, right? Yes? Okay, cool. All right, so what do we have? Higher order derivatives, tangent line stuff. Okay, this will set us up pretty well. Okay, mention this, one of the early days with derivatives, higher order derivatives, and what the notation looks like. So everything we have found so far has been a first derivative, right? It's been f prime, y prime, h prime, whatever it's been. And so that's what that notation's all about. So y prime of x, f prime of x, h prime of x, things like that. So that's what we've been doing. You find a derivative using a power rule or derivative of cosine or sine or tangent, whatever it happens to be. How do you think you get a second derivative? Do the derivative of a derivative. That's right. So the second derivative, y double prime. Yep. Y double prime, f double prime, h double prime. All those would be notations. Of course, first derivative, you could use the Leibniz notation, dy dx. Second derivative, you could use the Leibniz notation, d squared y over dx squared. That's the other notation that you'll see. And then how would you think you would find a third derivative? Just do it again, right? Yeah, exactly. So the third derivative would be y triple prime or f triple prime, h triple prime, whatever, and then using Leibniz's notation, d cubed y over dx cubed. It's a great question. I'm not interested in answering it totally yet, other than, well, maybe I will. So I hinted at this a little bit a second ago. Remember how I told you that d dx is an operator? Like it's find the derivative with respect to x of whatever comes next. So it's a verb, right? It's do this. Okay. So if I do d dx of y, this would be like a first derivative. Right? So like y is just like the function. And so d dx of y would be the first derivative. So you think about this symbolically, d dx of y is really dy dx, like the y is like a numerator. So check this out. What if I wanted to find a second derivative? Wouldn't that be d dx, not of y, but d dx of dy dx? So then you think about symbolically, you're not really squaring anything, but it's how they decided the symbols would work. You see on the numerator, there's a d of dy. So there's like two d's. So then you say, all right, well, that's like d squared. And notice in the denominator, it's dx dx. So technically, it probably should be this, but we just don't put the parentheses in there because we're lazy. That's kind of the origination of the symbols. Nothing's being squared. It's just what the symbols are. Okay. We good? All right, so with that in mind, I'm guessing you can probably do number 8. Maybe you've already done it. So please try number 8. Find d squared y over dx squared, also known as the second derivative of y with respect to x. And we'll get in, as the year goes on, we'll get into more about the what does the with respect to x thing mean, because could it be with respect to something else? Of course it could. It could be with respect to anything. Anything. You know what? Smiley faces, trees, dogs, I'll use it all. Whatever. Got any soccer stuff coming up this weekend?
Yeah.
Is that a silly question? Is that pretty answer always yes?
Every single day.
This went well for you. If you're going to find the second derivative, you need to find the first derivative first. What did I give you? Did I give you the first derivative? Didn't I give you like the function, like the original function, if you will? So that's another, like kind of back to the question I think that we were talking about with Ben a little bit, or whoever that was. Every now and then, think about this. I might give you the first derivative. I might say, hey, here's f prime. Find f double prime. Think about that. How many times would you actually do the derivative? Once. See what I'm saying? You got to pay close attention to what you're given and what you're expected to find, because it'll make a difference. Okay, so this time we do just have the original function here. So for f prime, do you guys just use the power rule a couple times? 48x to the 5th minus 50x to the 4th plus 15x squared. Did I do all of my arithmetic right, I hope? All right, so then to find the second derivative, we just basically do it again. So 48 times 5 should be 240. X to the 4th minus 200, x cubed plus 30x. That would be your second derivative. And if we wanted to, we could say, to match up the symbols, that is equal to d squared y over dx squared, and we're done. Question?
Can you take out an x to the third and then do it?
Sure. So you could do a number, like at the very start? Okay, let's talk about that.
I did it and I got a different answer.
Well, let's talk about that. You might bring up a very worthy talking point. So let's see what happens here. Do you guys hear Addie's question? So let's look at this. So if I do that, if I say f of x equals, and then I factor out the x to the third, that would give me 8x to the third minus 10x squared plus 5. Right? There's absolutely nothing wrong with that. What? Don't you have to do the product rule? Yup. Now you do, because you took something that wasn't a product and you turned it into a product. So now if you're going to differentiate this, you got to do 1d2 plus 2d1. Does that make sense? So guys, this is another awesome example of, honest to God, I would have never thought of that, but because she brings it up, we get one more chance to reinforce the product rule. So if you ever have a question like that, don't be like, no, he doesn't want to hear this. I probably do. Have the courage to be like, yes, I have a question. Even if I think it's like the dumb question, which there really is no such thing, right? I mean, just ask it. It's cool. Very good. So it makes sense, Addie?
Yeah.
Solid? Okay. And if we had like gobs of time, I'd have you all do the product rule with that and see if it matches up. But we don't have gobs of time. All right, so finally number 9 says find y triple prime if y equals 2 minus 2 over x. How do I want to say this? Can I encourage you to be strategic? Like have a strategy, like have a very definite strategy about how you want to handle this. Don't say it. Maybe you have it, maybe you don't. I don't know. Don't ask anything. I want you to think about it. Just think. And you can make this really easy on yourself or really not easy on yourself. Maybe that's what you're thinking. I don't know. But shh, don't say it out loud. I want people to think. And I don't know what you're about to say, but if you say it all loud, you might ruin their chance to discover it. So what were you going to say?
Would it go to
Which 2? There's 2 of them.
2 at the beginning? Would it just be 0?
The derivative of a constant term is 0. Yeah.
Okay, even if it's done several times?
Yeah.
Okay.
The derivative of 0 would continue to be 0. I'm sorry, I probably should have made one of them something other than a 2, right? A 2 and a 5. The bigger one, yeah. The large 2. The one that stands out. Okay, I don't want to leave you in the dark for too terribly long. So I do want to ask you this. Did anybody think of the strategy that would make this potentially way easier? you guys do any manipulation before you started doing derivatives? What do you think, Jake? Isn't that it? Move the x up. Because if you don't move that x up, what do you have to do? Have to do the quotient rule, and it's actually just going to get more and more complicated as you do it because you got to do 3 of them. So I agree with that idea that we would go y equals 2 minus 2x to the negative 1. If you do that, this just turns into a series of power rules. It should be relatively straightforward to do. So let's try this real quick. Y prime, what's the derivative of this 2? Because isn't that a constant term? So the derivative of that 2 is 0. But then if you do the power rule, you get 2x to the negative 2. We keep on rolling here. Y double prime then would equal negative 4, x to the negative 3. And then y triple prime would equal 12, x to the negative 4th. So flipping up there would make, I think, a lot of difference. All right, let me see how I want to finish. We got about 3-4 minutes left. I don't know what I want to do here. Can you tell I don't pre-rehearse these things? That's why I have a notes packet so that I can follow the plan that I already set out. Okay, do I want to do that one? Let's do this. I'm going to skip around a little bit. Will you guys jump to the end? We'll come back and do those other ones on Monday. I would like to do this one here. So get us set up, I think, in a good place. Okay, so motion functions and higher order derivatives. We have talked about motion functions. We did a little bit last time. We started off today's class with this. We'll finish with this. So let's remember the first question. We already talked about this at the start. What is the derivative of a position function? It is a velocity function. That's what we did with the guy diving off the diving board. Then what would you suppose would happen if we differentiated that? It's acceleration, right? It's the rate of change of velocity. So that is called acceleration. So when you have a fast car and they say, hey, this will go 0 to 60 in like 3.5 seconds, which is like crazy fast. They're basically saying you're going from 0 miles an hour to 60 miles an hour, and it only took you 3.5 seconds. It's a really big acceleration for a car, at least. If 0 to 60 took you 10 seconds, not nearly the acceleration, right? You're not going to feel that like you would with a really fast car. Make sense? Okay. All right, so an example of this, you've got a car doing the opposite. It's going 66 feet per second, and somebody hits the brakes. It says selected values for the velocity of the car are given below. V is measured in feet per second. T is measured in seconds. And then it comes up with this word right here, approximate A of 2. You guys remember how we talked about approximating last time? Aren't approximations just based on the tools and data that you've been given? What's the only thing we have? Yeah, data table full of points, right? And I'm supposed to approximate A of 2. So how does acceleration relate to the table?
It's the derivative of the table.
It's the slope of the table, isn't it? Or the derivative of the table. So if I was going to approximate this, what would I have to use? Because if you can't differentiate, that's fine. Remember the saying? No, if you can't differentiate, that's fine. Just use the slope of the secant line. I should make you say that out loud, but we only have a minute left, so I'm not going to. I'll make you say it next time. How about that? All right, so if you can't differentiate, that's fine. Just use the slope of the secant line. Which 2 points would I use? You guys suggested 2 points.
50, 26.
Yeah, these 2 points right here. Why would I use those 2 points?
It's in between one.
Yep, 2's right smack in the middle. So I would say A of 2 is approximately equal to V of 3 minus V of 1 all over 3 minus 1. And what's V of 3?
26.
Minus 50 all over 2. So 26 minus 50 is negative 24. Over 2 is negative 12. What kind of units go with acceleration? You get the squared, right? Because it's feet per second, because it's a rate of change of velocity. So feet per second squared. All right, well, I think I've gotten to a pretty happy place, and thankfully that is the case because it's time to go. Hope you guys have a wonderful weekend.